thank you for having me here. It's a great honor to be here at ITBN, a big conference about security. We're thrilled to be able to talk to you about what is happening in the security world at the moment and how we're dealing with that. Sorry, yeah, I need to be a bit closer to here. The subject, leading the world into connected security. What do we mean by that? And I think if you have listened to the previous speaker, you see resemblance in what we talk about. But I think what is interesting is that we've been working and thinking about what can we do to help organizations to really get to that. So this picture is very similar to what we've heard before. In the past, organizations have been looking at security in a siloed way. If they needed something to protect their endpoints, they looked at all the vendors of endpoint solutions and they figured out, okay, let's buy this one or that one, usually looking at the analysts. If they needed to protect their perimeter, they would do the same, looking at firewall protection, looking at vendors and bought their solutions. So it was growing and growing, but necessarily not providing you with better security, because all those solutions were only supporting a technical security need and not necessarily the overall need. So what we have been looking at for quite a while now is how can we change that? Because if you look at this picture here, you will see that organizations start to buy point products. The investment was maybe not that high at the moment, but the security level, the security posture was not necessarily that high either. So after a while, organizations said, no, we need to do something different. And I heard my previous speaker mention that same word. We need a layered approach. And when I talk to organizations, they quite often still say that. They say, you know, if we have, for instance, some endpoint protection from McAfee, if we have some protection by firewalls from Check Point, we have an IPS from somebody else, you know, one of those technologies will find out what's wrong and they will hit it. The problem with this is you're spending an awful lot of money trying to get protection. There's a lot of overlap in all those products as well. But does it really give you better security? I don't think so. It gives you a false feeling of security because you're spending a lot of money. You think, okay, I must be secure. Let's have a look at some of those examples. And we got an example before as well from the New York Times. Here you see some examples of organizations and even also states and countries that spent a lot of money. I mean, they were well-funded organizations. They had a lot of money. They spent a lot of money on security, and yet all of them were breached. So something clearly is not working. So let's take an example. It was end of last year when Target was hit. They were breached. They didn't know what was going on. Actually, in their log files, the information was there. So they could have known what was going on, but they didn't figure it out. One of the reasons is because they had a massive amount of alerts. How do you find out from all those alerts which ones are really serious, which ones you need to look at? It's very difficult. Another example around Target was that, you know, they had lots and spent lots of money in trying to be compliant. They have to be. They have to be PCI compliancy, the payment card industry standard, throughout the breach. So before the breach, during the breach, and after the breach, they were compliant. So they were PCI compliant, and yet they were breached. And 118 million records were stolen, credentials were stolen. So compliancy doesn't necessarily mean security. So you see all those organizations. Take in this another example, the state of South Carolina. Very similar to the New York Times, a phishing attack. One person opened a file, it imported a Trojan, and somebody was in their file system for 2 weeks looking at over 3 million social security numbers and 3.8 million bank accounts. So, you know, despite the fact that they had security, they didn't have, and in the end, we figured out that 74 gig of information was exfiltrated. They didn't have the tools to figure out that that amount of gigabytes was exfiltrated. Another one is South Korea. Everybody is probably aware of Dark Seoul. where, and they say it comes from the country north of them, of course, that all their ATMs and a lot of other television stations and stuff like that, they were all kind of out of the air for a while. And that's how they found out that antivirus today is definitely not enough. So a lot of money spent doesn't mean that you're secure. So what do we need to do? And the previous speaker mentioned that as well. Cost. We need to take care of cost. We actually want to try to drive down cost, but at the same time, increase your security posture. How we do that? Well, the way we've been working at that, the way we've been looking at that, and actually we've been working on that since 2001, is to create something that we called connected, a connected architecture, connected security. To switch gears just a bit, to give an explanation of why today I am here and I'm saying I'm Intel Security. McAfee, the largest dedicated security provider in the world for a while. They have lots of products, a lot more than a lot of people envision. When we talk to people, they say, yeah, we know you from antivirus, we know you from maybe endpoint protection, but not necessarily they know that we have a lot of network security products, we have security management products, we have over 100 products, and quite a few of those are in Gartner's leader quadrants. So what did Intel do? How did Intel come to all this? Well, Intel, I'm sure that lots of people know. Intel is actually one of the top 10 brands, most influential brands according to Forbes. They're in the top 10, they're at number 8 today, along Microsoft, Google, and Coca-Cola, for instance. But what a lot of people also know is that they were the inventor of the world's most widely spread computing architecture. What they might not know is that Intel was also at the brink of the USB and Wi-Fi. So Intel has always been spending a lot of money in trying to define new architectures. And that is actually why they were looking at McAfee. The security knowledge that an organization like McAfee had, combined with the forces of Intel, a lot of people, a lot of money, trying to deliver basically what we now call the next generation of security architecture. And what people say, and the person from Checkpoint said it as well, we need to change the world. We need to make a change to where we are today. Why do we need to make that change? Because at the end, what we want to do is we want to create, and everybody's talking about this, large organizations are talking about it, we need to define new data centers. We want to go to the cloud. We need to save money by going to the cloud, by making more efficient use of the power of our machines. We can save a lot of money. And the Internet of Things, that was explained just before as well, everybody's using all these kind of devices. How can we make sure that we do that in a secure way? How can we make sure that if people are using those devices, we are safe? And this is something that came up long time ago. We have done investigations where we talked to CEOs of large organizations, and they said to us, like more than 80% of those organizations said to us, we have stopped innovations. And if innovation is that's the blood of organizations, that's what they need to do. But they said we have stopped innovations, and the main reason was because we were not sure about the security risks that we had. So definitely we need to do something. We want to do something. We want to help organizations to create this new architecture, an open architecture, an architecture where every organization can exchange information with other organizations. Not by APIs. I heard that word used just before as well. I think APIs don't work in the world where we go to. And I will try to explain why not and where we're going. So the first part of it is actually what happened like 13, 14 years ago. Organizations came to us and said, we need to do things in a different way. We need to have a consolidated architecture. We need to make sure that from all those solutions that we had, and you have seen lots of blueprints of that, the operational complexity is too big. We have lots of different teams in our organization. They all have their own dashboards. They all have their own data, their own information, but it is not linked together. And I have no idea where to go if something happens. And we need to make sure that we do something about it. So what we did is try to help organizations by doing that, by making sure that we didn't need all those consoles anymore, by making sure that we had lesser and lesser agents that we needed to spread out, so that it was a lot easier to create your policy management and to maintain the security policies in your organization, and at the same time you would also reduce your computer processes, your computer power that was needed to run the whole show. This was a long time ago when it all started. The next thing that happened was, of course, money. You know, after the internet bubble crashed, organizations were starting to look more at, you know, where do I spend my cost? And of course, you know, investments in security, it's always difficult. What does it bring me as an organization? Well, it might not bring you anything. It might prevent a lot of bad things from happening, but how do you calculate how big that risk is and how much money is involved? It's very difficult. So we try to help organizations to look at that and say, how can we do that? How can we help organizations to reduce their budgets, but at the same time stay secure, to help them to create a lower operational expense, but remain secure? They needed self-provisioning. They needed things like a reduced infrastructure overhead. So that's what we helped organizations with, by virtualization, by creating cloud security, by making sure that we had fewer appliances. If you listen to the speaker before, you know, I see Checkpoint is going that way of creating, you know, a software security environment, making sure that organizations don't need appliances for everything they have, and making sure that with what they have, they can actually put it into the cloud, into a safe way. Now, we did that, and we have examples of organizations that actually saved a lot of money by doing that, that actually can prove that they lowered their total cost of ownership, that can show how they simplified their operations. We're not there yet. And the reason we're not there yet is because, as you just heard before as well, you know, the fraudsters are clever. You know, they are not sitting still. They come up with very advanced threats to us now. And looking at that, there is a need for something different. And the need is to create a framework where we connect security information. And that is really something, and I think this is something that will happen over the next few years, and it is very important we go that way. It started maybe a year, maybe a bit longer ago, when for the first time you hear organizations speak about the fact that they want to exchange information with each other. I was at RSA conference in Amsterdam, that's about a year ago, and I was sitting into some presentations. There was a keynote from somebody from Symantec that, you know, explained we need to gather all that data, we need to gather all that security information. And he said we need to put it in the cloud, and then we do some data mining in the cloud. It sounds great. The question is how we do that, because what we need for that is some kind of architecture where we can actually figure out where the data is and what kind of data we need to correlate with each other in order to find out what's really going on, where do I need to pay attention, and where, you know, I'm not necessarily at risk, even though I have a lot of data around that. I was in a session from somebody from the NATO, and he said, you know, what we need is a data exchange. What he said was, you know, we have all those member states. All those member states gather security information. Now, what we need to do is we need to make sure that they can all use all the information from all the member states. So his suggestion was to build a kind of a data exchange. And, you know, in NATO terms, that means you need to have a commitment from all the countries. They all have to agree. You need to find budget. And then he said, you know, in about 4 years' time, we hope that we have a data exchange. And what we want to do is make sure that everybody is going to, you know, hop on that bus, including the vendors. So after that, we've had some discussions with NATO about the fact that that kind of architecture is much closer than 4 years. In fact, it's almost here. So why don't we use what we have today? And how can we do that? How can we make sure that we open it up to everybody? And that is what we're doing. That's what we're trying to talk about today, is what we call a data exchange layer or a data exchange framework that will provide the means and a way to do this in a much more efficient way than we used to. And what is the difference? It's not based on APIs, because that means that you need to integrate everything to everything. And if you look at how many players are out there, I think there's over 800 vendors of security solutions. I'm sure that every government body, every organization, certainly the large enterprises, they have 10, 20, maybe more different security players there. How do we do that? How do we create all those integrations with APIs? It's basically not working anymore. So what we try to do is we create what we call the data exchange layer. And for those people like myself that have a past in middleware technology, basically this is what I would call a middleware layer, an enterprise service bus, as some might call it. What we try to do is we try not to use APIs, we try to use services to exchange information. And so what you can see here is a message bus. The message bus will provide the integration, not the APIs. It's using services for that, and what we need to do is make sure that we create standards. And this is what Intel is actually trying to help organizations do, to create standards. As an organization, I think McAfee was way too small to actually come up and say, hey, we created standard and maybe everybody can hop on that bus. With Intel, that has been at the brink of USB and Wi-Fi and other architectures, I think there's a chance that we can do that. That we can create a structure where everybody, not only all those member states, but also other organizations, including vendors in the end, can also link into and create that integration that makes sure that you get all the information that you need to become safer. We need to create intelligence from that. And so we create this service bus. It will be secured. I mean, there's ways. We're using TLS for the technical people. We use TLS. We're using certificates for authentication. So the exchange of information using those services will be secure. And so we're going to do that with, for instance, a number of different ways. We can do what we call a publish and subscribe. So one system can publish information, other systems can actually pick up that information. What we do now with our API integrations, we throw away probably 80% of our security data, because that other system can only handle so much information. It's a different system, it has different attributes. So from the information that I gather from maybe my endpoints or maybe my firewall, maybe half of it, maybe less than that, I can actually send to the other system. What if I have what we call a common information model, save all the information, and then let all the other solutions actually grab anything they can get? So I can publish it in one go, every information I can publish. Then others can publish the same information, so I get a complete filled data model with security information, security data, and then every other organization, every other system can pick up everything that they can handle. By that way, we do not throw away any security data, but we leverage. We collaborate all the information, and we have different solutions that will help us to trigger what's really going on. That is what our data exchange layer is going to be. It's based on open standards. For those that are aware of that, it's based on actually IBM technology. It's MQTT, it's called, and based on top of that, we have something called Mosquito. We're using standard information, and at the booth that we have over here, you can see a lot more details about using STIX and TAXI as kind of standard protocols that we use now in the security world to exchange information. So basically, we try to make it open, and we try to open up that data exchange layer to everybody. There's already discussions going on, and you see the need. I was talking to some financial institutions in one of the other countries, and they are already actually exchanging information like that. What they don't have yet is the architecture to be able to run that smoothly. And that is what we try to help organizations to provide. Now, I want to make sure that you don't get out of this room and say, hey, I can only do this if I buy all the Intel security products. That's definitely not what we want to do. It is not a single vendor solution. It is not a solution where we say, throw away everything you have. No, what we try to do is make sure that whatever you have can be used in that environment. It's not what we call a monolithic architecture. It's not a big rock that cannot be changed. what we want to do, and that's why we're using this middleware technology layer, is to open it up, to make it flexible. Because now, if I have 9 systems and they're all integrated to each other, I change one system, I need to change 9 or 8 APIs, basically. In the new situation, in the data exchange layer, I don't. I'm going to change that one thing that is changed, that new version, and the rest will still pick up all that information. You might add to it if you say, hey, I have now more security information, so I want to pick up, and other systems can pick up that other information as well. You can make those changes. But it's a lot more flexible, a lot easier to use than what we have today. You don't have to continuously add new products to that. You have already a lot of products in-house. What we try to do is make sure that we can leverage all the data, all the security data from those, and use it in the best way possible. And as I said before, it is not a massive rip and replace. So coming to this final slide, I want to give you an idea of what it means. I mean, I'm talking about a data exchange layer, yeah, but actually what is it? How does it work? Well, it's providing the elements that can be used in an organization like this. So what you basically see is I might pick up a file in my antivirus system, and I'm not sure. I haven't seen it before. I mean, this is the problem. Antivirus, it's all from the past, right? We create signatures from things we know. But now we receive something and we have no idea. What it will do is it will go to what we call a threat intelligence exchange. And that threat intelligence exchange has all sorts of information in there. So it will check this file in a different way than an antivirus can do. It will try to find out, was that file H hidden, for instance? Because if it was, there might be something fishy about it. It can see if the signature was revoked. It can see if it was created by an untrusted process. All that information. Now, what it can do as well is it can go to what we call the global threat intelligence. But organizations might also have what we call local intelligence. So what we want organizations to do is to hook up that local intelligence to it as well. So if the McAfee sensors didn't pick it up, maybe somebody else or some other system that you have in place might have picked it up. So we can check that against everything that you have today. And by doing that, we can make sure. And then in the end, if we have never seen it before, the last resort is kind of sending it into what we call an advanced threat defenses. I'm sometimes using the word sandbox, but it's not necessarily just a sandbox. But it is an environment where I can put that file and I can take that file completely apart. I can reverse engineer it and bit by bit check if we think there's something wrong with this file, yes or no. And then finally, we're going to make that decision whether this file is fine or not. So what we try to do is we try to use all the information that we have. And using this data exchange layer is making sure that we can hook up everything that we have. And in the future also everything from other vendors as well. And then make sure that we check exactly what's going on. So a lot of this process needs to be automatic. You don't have time, you don't have the people to check every file in this way. So what we want to do is make sure that we automate as much as possible about this, and that only those where we say, hey, there is something here and we are pretty sure it's wrong, but we want you to have a look at it and to make a final decision that it is or is not wrong, that's when we go. But make sure that we handle 99% of all the information that we get, all the security stuff that we get, make sure that we handle that in an automatic way, because you don't have the people, you don't have the money to look for that. So with that, I'd like to conclude the presentation. So I'm very excited about this threat intelligence exchange. It will be released, this first example of it, over the next coming couple of weeks. So watch the news, I would say, and I'd be happy to talk to people about this in more detail if you have any interest of it. Thanks for your attention. My time is up, so I'll give it on to the next speaker.